Right, and so you would expect in a normal distribution, this bell curve, right? If it's a proper bell curve, everything will equal each other. The mean should equal the median, should equal the mode. So that's how you distribute it. Fair question, they could ask you that. And then we'll look at the skews in a second. Now, these numbers are going to be very important. When we talk about one standard deviation, 68% of the grades or whatnot should fall in between that. And then if you go to 2 standard deviations, 95 should, and then 3 standard deviations, 99.7. So you definitely need to remember these numbers down here to know what falls within what. I think the trickiest thing they could do is if they say some person fell below the average, below the mean, but they were still within 1 standard deviation, okay? So how would that work out? If they fell below the mean, right here, but they were still standard deviation, you don't want to put 68% because they're below the mean. You would get this 34%, okay? Hope that makes sense because, so it's important to know not only the standard deviation, but sometimes if they tell you which way you fall, to know you have to half it from the original number. Okay, I think that's as difficult as they can make it on you guys. You probably came across some practice questions like that. So they like these numbers a lot. So make sure you know those. A little bit more of the same. So it's 1 standard versus 2 versus 3. You can see that there. And this is just from first aid, kind of outlines everything for you guys. And we'll look at standard error of the mean in just a second. All right, so what are we looking at here? So, you know, we can still appreciate the fact that here our mean and median and mode are all going to be the same, right? But what's different? Well, our standard deviation is different. If we look at the yellow line, our standard deviation is right there versus the blue line is kind of centralized, right? So what would you consider a more, okay, so say you were writing a test, what would you want better, right? You'd want, you know, you'd want it to be a closer or a lower standard deviation, right? Which means the students kind of fell in a better range, a more, you know, the values didn't fall, you know, erratically around the mean. And, you know, that's with any research paper or whatnot. You kind of want your numbers clustered toward the center because that kind of gives you more validity to it. And what you'll find is, and this is kind of a good point to be made, that's kind of where standard error of the mean comes in. The increased number of data points you have, subjects, test scores, whatever, the closer you're going to get to the mean. All right, the closer you're going to get to this blue line. And that's just because statistically, the more values you have, the more you're going to fall around the average. Now, you may have a few outliers, but when you look at the entire dynamic situation, you're going to fall more towards the middle. So it makes the more values you have, the more valid test, right? That makes sense. The more subjects you have in a research or in some sort of trial, the more valid it'll be. Okay, so yeah, and this is kind of what I was just explaining here. So smaller becomes narrower, and then if larger standard deviation, it becomes wider. So they very well could ask you that on the test, giving you the different graphs. Now, this is fairly straightforward when we look at precision versus accuracy. So precision, yeah, I have a better illustration of this, yeah, coming up. So precision is like clustering, okay? Like if you were shooting at a target, these clustering. Pull up the pen, come on. Or not. You can see here that there's clustering, right? They're precise. When you shoot the gun, they all come out in a cluster, right? So this shows high precision. Means everything, all the shots fall in a certain range. Now, accuracy, you're trying to, this is where you're shooting for. All right, so you have precision, you can pinpoint it, but you're not shooting at the target. So if you look at this graph here, you can see that it is accurate. You know, if you average all these out, they kind of fall towards the middle, but they're not exactly precise because they're not in a clustered set. Ideally, you want everything accurate towards the bullseye and clustered, which will give you increased precision. I do have another picture coming up later on when we talk about it. But yeah, so I remember we did have a question like this. They gave us these little bullseyes, asked which one is precise and accurate or whatever. So easy points there. All right, so when we look at skew distribution, you always define it by which way the tail is going. So negative skew, right, if you want to graph, is going to be pointing to the left. A positive skew is going to be to the right, right? And then we'll look at coming up. Okay, this is super important. Whenever you have skew, so which way is this skewed? Positive skew, right? The tail goes to the right, positive direction. This is always going to be the case. The mode is going to be in the middle, right? The most common number. The median, the middle number, will be next, and the mean will be the furthest. So you would always expect the mode to come first at the peak, the median to come second, and the mean to come third. The mean is going to be always towards the tail, whichever the tail side is, right? So if we looked at this the other way, right? If we had a tail this way, like, whoops, that's awful. Okay, like that. Actually, let me do this. If we had a tail like this, it's not even very good. Let's see. We'll call that a tail. All right, so always find the mode first. That's your top point. Median comes in, so we have a negative skew, right? Negative. Median's going to come next. And then the mean will be third. All right, very straightforward. I just wanted to point this out for you because I would venture to guess that you will have a question like that. All right, cool. And you can see this here. Again, we talked about this bimodal distribution, and then whichever way you're looking at it, find the mode first. That's your top peak, and everything else falls towards the tail, median next, and then mean.